My name is Mukunda Ravapali, and I'll be presenting on Google Cloud's Vertex AI platform for my final cloud computing presentation. So, what is Vertex AI? Vertex AI is a fully integrated cloud service that Google provides in which users can train their machine learning models. They can train, test, and deploy their models all through the cloud system. The Vertex AI solution has been integrated with other Google Cloud services. So this makes it seamless for a user to gather data from the Google Cloud Storage or BigQuery or other data services that Google Cloud offers. And they've been integrated with lots of other services which will enhance a user's machine learning model. The pricing varies for Vertex AI depending on how many Google Cloud services you're using to train a particular model, but the bulk of the cost revolves around something called the node hours, and this is basically a term which defines how long and how much of computational resources you're using to train your machine learning model. We see that the Vertex AI solution has been taking off in the past year, and big companies like Forbes, Symphony, Fox Sports, and Datadog have been integrating the Vertex AI solution into their platforms. So let's take a look at the details, and if we look under the hood, we can get an idea of how Vertex AI works. So there are 5 main steps in the machine learning process. The first is data preparation. Then the user trains the model, and then we would evaluate the model, and then finally deploy the model either in the cloud itself or online using HTTPS mechanisms. And then we would finally want to have a way of monitoring the model as it evolves. So let's look at the data preparation section. In this, the user would upload their data, and many times perhaps there are missing values in the data, or maybe some of the data points are not aligned properly. Well, Vertex AI has an integrated Jupyter Notebook interface called Workbench, in which users can input Python code to quickly clean up their data and maybe fill in certain missing values with either the average of the column or through the most frequently occurring number of the column, whichever method is most appropriate for that data. Users can also visualize their data set by using something called the EDA, the Exploratory Data Analysis tool provided by Vertex AI. Next, let's move on to the model training part of the machine learning process. And this is where Vertex AI really comes in handy because they have a host of different selections that you can use to train your model. They have something called the model garden, in which you can use AI tools. You can present a data set to your AI, to the AI tools, and they will allocate the different types of techniques which seem best suited for that type of data. Apart from that, Vertex AI also has something unique called AutoML, in which their AI systems will train, they can train text, tabular, image, and video data without the user having to input any code. And this isn't as customizable as their custom training option, in which this is for more developed and experienced users. They can input Python code and customize the machine learning model as much as they would like or as little as they would like. But the AutoML has really democratized access to machine learning training for many users who don't know how to code. And after this presentation, we will be doing a quick demo of AutoML using tabular data. So we can go into more detail about that later. Vertex AI also has something called Vizier, which helps tune hyperparameters, and they also have something called experiments, in which users can train different models and train the same model, the same data, and with different techniques and compare the results side by side. Then we have model evaluation. So these are metrics that help us decide how well the model is performed and how well it's able to predict data using metrics such as receiver operator characteristics, ROC curves, or precision recall curves. Then we have model serving. We can either deploy the machine learning model within the cloud using and then keep updating it using batch training, or we can upload it onto the web using HTTP protocols and then use online training to continue to evolve the model. Then lastly, we have model monitoring, and this is a way to keep track of additional data that's added onto our model. It's a way to make sure that we don't have any data skews or prediction drifts. Here's a visual diagram that basically illustrates the points that we talked about earlier. On top, we see that we have the different steps of the machine learning process: ingestion, analysis, transforming the data. These three things have to do with uploading and cleaning up the data. We see that we can use other data sources within the Google Cloud platform, such as GCS or BigQuery, in order to add data into our models. And then we have the different training mechanisms that we talked about with the no-code AutoML or custom code. We can even use models trained outside of the cloud and bring it into the cloud to further train it. Then we have the evaluation side with things like ROC and recall curves to demonstrate how well our model did. And then finally, we can either deploy it within the cloud or deploy it online. So this is just a look at some of the evaluation metrics that we spoke about. We have the precision recall curve, the ROC curve, and here is something that we call a confusion matrix. And basically this depicts how confused or how clearly the model was able to perform. And we have things like true negatives, true false positives, true positives, and false negatives. And these metrics basically help us understand how accurate the model is. So let's go ahead and take a look at a quick project that we can do to really demonstrate the power of Vertex AI. So I've pulled up Kaggle data sets over here, and we're going to look at some binary classification data. And if we scroll down, I'm going to go ahead and select this employee data set. So this data set has, so we see that the data set has 8 different factors and 1 target column. And the factors are education, the degree that the employee had, their joining year into the company, the city in which they're located, their payment tier, age, gender, ever benched. So this indicates if an employee has ever been, if there's been a time where the employee didn't have any work to do, and then their level of experience and the number of years in their current domain. And basically what the data is trying to analyze, what the model is going to be analyzing with this data, is whether or not a employee plans to leave or not. So I've already gone ahead and downloaded this data set, and we have it right here. So let's go ahead and take a look at the data. All right, so we have again here the metrics clearly laid out for us. We have their education, bachelor's or master's degree, their joining year, the city in which they're located, their payment tier, age, gender, ever benched, experience in their current domain, and this is our target column, whether they're going to be leaving or not. And notice that we either have a 0 if they're not going to be leaving, or a 1 if they do plan to leave. So let's go ahead and upload this data onto Vertex AI. So I've opened up, let's start with Vertex AI dashboard. So this is what a user would see once they pull up the Vertex AI system. And let's go down here to our data sets. And we're going to go ahead and create a new data set. We'll call this final project data set. And as I said before, Vertex AI can work with images, texts, and videos. But for this project, we're going to be working with tabular data. And we're going to be doing a regression classification because we want to classify whether an employee will be leaving or not. So we're going to go ahead and create. All right. I'm going to upload the CSV from the computer. So all right. And I'm going to go ahead and store this in a Google Cloud bucket that I opened. This is equivalent to the AWS S3 bucket. Continue. All right. And we're going to go ahead and we're going to train this model. And usually it takes about, so we're going to use AutoML to train the model. Say, okay, we're going to hit continue. Going to choose our demo bucket 1 to store the output data. Continue. And we got to make sure to choose leave or not as our target column. This is a very important part. Objective is classification. Okay, we're going to skip the description for now. Continue. Okay. And so this is what I was talking about earlier with the node hours, is basically how much of computation power we want to use. So I'm going to go ahead and choose 1 node hour. This means that the model is going to run, it's going to get trained for 1 hour, and how much ever it's trained at the end of the hour is just going to terminate. And if it's able to completely finish its training earlier, we're going to go ahead and stop it, and that'll save us cost and resources. So I've enabled this early stopping feature right here. So normally I would submit, and then this will run for about an hour, and then I'll get an email once the module's finished running. But I already went ahead and trained this data set earlier so that we don't have to wait. And I trained the exact same data set. Everything's the same. It's just that we're skipping the waiting period. So I'm going to go ahead and pull up the results from that trained set. And this is what we have here. So this is the employee data set that we trained. And we see that these are the feedback metrics that we got. So we have our ROC curve. This is our threshold for the amount of false positives we had. This is the precision versus recall curve. And if we look at our confusion matrix here, basically this, what it's telling us is that whenever the value of the leave or not column was 0, the model correctly predicted 0 about 96% of the time, and then about 4% of the time it got it wrong and predicted 1. And whenever the actual value was 1, the model correctly predicted a 1 61% of the time, but then it got it wrong around 39% of the time. And then here we can visually see the output. So what I went and did was that I added an additional batch data. I'm going to show you here. So we have our current data that we trained it with. I went ahead and created random factors for each column. So their education, joining year, city, all the way to their experience in current domain, and then we see their the last value in the each row is whether they're going to leave or not. So all these are random values that I came up with for 10 different rows, and then I saved this as employee test data, and I went ahead and I created. We have batch predictions. So I created this thing called employee batch prediction. So I re-inputted those 10 random data sets back into our model. And this is the output, the predictions that we got for each model. So if we look at one of these, so this is basically what the model said. So for this, all the columns are the same, except we have two additional columns, which is the leave or not 0 scores and the leave or not 1 scores. And so this is the 0 score here, the 0.704 value, and that's basically the percent of confidence the model has on whether it thinks that the person is going to leave or stay. So here, and we set the threshold at 0.5. So anything above 0.5 means that the model believes that it's going to leave, and then anything under that for the leave or not score under that means that the model believes that the person is going to stay. So here there were actually two wrong predictions. So here the actual prediction was that the person was going to leave, but then the model predicted that the person was going to stay, since the leave or not score for 0 is higher than 0.5. And here, the actual value is that the person is going to leave, but the model predicted that the person would stay. So for each of the 10 predictions, we had the results, but then they were all displayed in different URLs. So what I did was compiled all the results onto a spreadsheet here, and laid it out side by side with the actual results, and this is what we get. So this is the score, the 0% score, and the 1% score for each of the predictions. And our model basically predicted it out of the 10 predictions, it made 5 incorrect predictions and 5 correct predictions. So this could be due to different reasons. Maybe there wasn't enough training data. We had around 495 samples in the training data, so maybe it needed more to really understand what was going on. Or maybe the factors are not a strong indicator of whether a person is going to leave or stay. So the different columns that we saw, like their age and number of experience and their master's or bachelor's degree, maybe those factors weren't strong enough in indicating whether a person was going to stay or leave. But we saw here how well Vertex AI can basically train the model, and we can easily implement more predictions in either batch or online predictions, and we can make further changes to the model at any time, and it's all saved on the cloud. And this is an extremely valuable tool for machine learning researchers. And as we've been learning throughout this class, the cloud has really integrated a lot of different components of computers, whether it's with hardware, software, and now even with artificial intelligence. And this certainly is the future.